Wow, your hardware can help manage privacy for you? That's a good news. And many cloud providers do that. Let's talk about this confidential computing concept today. Welcome to my YouTube channel where you regularly see new content on data privacy. And as I said, let's talk about confidential computing in today's video. So, what is it? It's a matter of saying, but let's understand the problem first. You secure your data using encryption. When you collect it, when it is getting into your data center, when it is going out of your data center, it is kept encrypted. When it is being stored on your disks, then also it is encrypted. Maybe twice, right? On collection as well as when stored. We call it at in transit and at rest, or maybe only once and kept at rest. There's no protection in use in this case. And what you want is that you want to put your data on cloud, which is another big task. So these are the various data exposure points which brought in confidential computing. Confidential computing, which says that I want to protect my data during computation. The data comes in, encrypted input, you want to compute it, very good. I'll decrypt and compute it inside the CPU and not on the disk, not on the software, right? So there's a secure enclave area on your CPU which does the processing and gives you the analysis, a secure encrypted output. So you are using isolated hardware environments to secure your data. Secure enclaves or the trusted execution environment, we spoke about it in a couple of days back as well. That is the mechanism that helps here. It's a confidential computing architecture plus cloud. It exists in major clouds as a foundation. Real world use cases, healthcare, finance, cloud, AI, ML, they all use them. Why do they use them? Because they need to put the sensitive data even more secure. So secure artificial intelligence, machine learning workloads, protecting your encryption keys and digital signatures in this secure area so that they stay safe, securing multi-tenanted processing, protecting workloads from cloud admins and root users, and of course financial risk and healthcare analytics. So the idea is that you are either securing your keys, encryption keys, digital signatures in this secure area. And it happened with me once where one of my customers to whom I wanted to sell a virtualization solution, they asked me, does it clash with this particular feature that all our hardware have? So what they do is they keep the data, it's a software development company, they keep their development code on the server, and the keys that are encrypting and decrypting these codes are stored on the CPU. So they were just worried whether our virtualization software would allow movement to the secure area or not. And if that is how it works, you have some dependency on the hardware, but you have more security than the software level encryption. So overall, it helps provide hardware enforced privacy, zero trust against any cloud service provider. It puts you in a strong compliance posture. DPDP and GDPR are supported. It enables migration of sensitive workloads and becomes a very key part of modern multi-cloud architectures. Cloud providers do use it to safeguard the sensitive information of their customers. Key takeaways: confidential computing is equal to privacy during processing, hardware dependent, away from softwares, built on the concept of TEEs, trusted execution environments, standardized across all clouds, most of them, and is essential for very highly sensitive workloads. We'll get into more details of confidential computing after some time, but from tomorrow we are going to talk more about the DPDP rules that have come up now in November 25 along with the timelines. Confidential computing is equally important because it sets foundation for the next generation security, especially around AI and ML. I hope you like the content of this video and you love to get into the details of the DPDP rules. So subscribe to my YouTube channel, share your feedback and press the bell and the like icon. Thank you.